Calculus kids, this is Dr. Callahan for AP Calculus Semester 1 for Week 10 Tuesday. So these are your 3 questions. Go ahead and pause the video and answer the questions on your new warm-up log for Week 10 Tuesday. All right, so I'm not sure if you guys ever use the Lime bikes, but I certainly love them when they were here in Reno. But I think a lot of people thought that it was more of an issue than good. So as you can see, there's no more of them here. But if you still go to South Lake Tahoe, you can still see them there. And I just thought, what an interesting place for people just leave the Lime bikes. And here are some interesting places that the Lime bikes were left. And seems a little tragic with some of these. All right, let's go and take a look at question number 2. So question number 2 asks you to go ahead and find the slope when given implicit differentiation with a 0.8 and 1. So this one is not so much as a difficult question as it does kind of review your skills when it comes to exponential powers in Algebra 1. So if I bring that down, just apply the power rule, I have a minus of 1, so I'm just going to put minus 3 over 3, which is a negative 1/3, okay? Plus, do the same thing with a y, power rule, 2/3 y minus 3 over 3 is a negative 1/3 equals 0. Oh, and I forgot a dy over dx, because derivative at y is always going to be a dy over dx. Okay, so then after that, what you want to do is you are going to rewrite this so that way you don't have any negative derivatives or negative exponents. So you have 2 over 3 x to the 1/3 plus 2 over 3 y to the positive 1/3 dy over dx equal to 0. I'm going to move anything that doesn't have a dy over dx to the other side. So I have a 2/3 y to the 1/3 dy over dx equals a negative 2/3 y, or x, not x, or y, x to the 1/3. Okay, so as I'm looking at this right here, I see that I have a 2 over 3 that I want to get rid of. So opposite of a 2 over 3 is if you multiply both sides by a 3 over 2. And so I'm going to multiply 3 over 2. So then this part cancels and I have 1 over y to the 1/3. Oh, what is going on? Stop it. Dy over dx equals 3 and 3 cancels, 2 and 2 cancels, to a negative 1 x to the 1/3. Okay, so then I want to give a dy over dx by itself again, but then I have 1 over y to the 1/3, so I'm going to multiply by y to the 1/3 on the left side and multiply y to the 1/3 on the right side. So that part cancels. Dy over dx equals a negative y to the 1/3 over x to the 1/3. So now that I have this, and this is my slope, I can go ahead and plug in the x and y values. So I have an actual concrete number for the slope. So, x is 8, y is 1. So then it is going to be a negative 1 to the 1/3 divided by 8 to the 1/3. And you can go ahead and write this as in like negative square root. And remember this, numerator is the power, denominator is a root. So you have 1 to the 1 power over cube root of 8 to the 1 power. So the cube root of 1 is just going to give you a negative 1. Cube root of 8 is going to give you a 2, because 2 times 2 is 4, 4 times 2 is 8. So your slope is a negative 1/2. And that is your answer for your slope, dy over dx. All right, let's go ahead and move on forward. So last time I saw you guys, we practiced with almost 8 questions. I asked you guys to do like a dead or alive, and you're supposed to practice with some of these questions. Make sure you do that. And then we proceeded on with a vertical horizontal tangent line of how to find a horizontal tangent line and the vertical tangent. by using implicit differentiation. So we did that. If you need to pause the video for number 57, here are the steps. If you need to pause the video for number 58, here are the steps. I know I asked you guys to do number 58 on your own because we kind of ran out of time. All right, and then today what we're going to do is we're going to move on to the following. So we're going to go over implicit differentiation day 3. So as you can see, each day we kind of build upon it to make it more difficult, make it a little bit more challenging. And that's good to have that pedagogical step because it's really difficult to master calculus if you decide to cram for it around April or May. You really have to incrementally build yourself, build your stamina so you can understand calculus. And that starts with pre-calculus and trigonometry. So already as is, if you did not memorize your trig identities or your unit circle back in trigonometry, you're a little bit behind, but that's okay. You can still catch up. I mean, there's still time because right now you are supposed to be memorizing the derivative of all of the trig identities, the derivative of the power rule, chain rules, and also the transcendental functions like ln, e, a to the u, log, etc. Next semester, semester 2, I'm going to have you guys memorize a new set of rules, which is going to be on integrals. So you cannot expect yourself to memorize everything all at once. You have to pace yourself. So make sure you catch up, especially if you are a little bit behind. There's still plenty of time for you to do that, but if you wait till the last minute, at some point in this class, it's going to be a little late, and I don't want anybody to be in that position. And once again, if you do need tutoring, make sure you go ahead and fill out the Google Doc or the Google form, and I'll be more than happy to meet with you individually for tutoring as well. All right, so take a look at what we're going to be talking about today. This is the breakdown. All right, and then go ahead and take a look or turn over your page over to your notes. Oh, okay, here we go. And turn over to page to week 10, Tuesday in your white guided notes. And you have a brand new guided note packet from Monday, which is going to last from week 10 to week 15. So you're going to have all of your notes basically outlined for you. This is page 1, page 2, page 3, or actually that's just page 2. There's 1 and 2. That's it. Just kidding. All right, so first thing I'm gonna have you guys do is take a look at page 1 right here in the blue area. You're gonna go ahead and just practice with these questions by yourself, and then the answers, my friend, are given to you right here, and essentially you're just gonna match them. Now, don't take my answers because these are not correct. I don't know what the answers are. I'm just randomly drawing them, but you're going to match them and just give yourself a little practice in how to go about finding the answers. So warm yourself up for the lesson for today. So pause the video and go ahead and do that. I'm going to go ahead and change this just a little bit. I'm sorry. I do this in the middle of this. So today it's slightly different because, like I said before, every day we're kind of building a little bit more onto the topic, and we're still on implicit differentiation, but it's a little bit different today because even though it is implicit differentiation day 3, we're going to do implicit differentiation by doing the second derivative. So you are going to find y to the second power, I'm trying to find my little caret here, over dy. So, or f double prime of x. All right, so now what I want you to do is pause the video and then take a look at the orange highlighted area. So this is going to be part of your guided notes as well. I did include the steps for you guys on finding implicit differentiation right here. I want you to go ahead and practice some of these questions from your textbook and give it a try, see if you're able to do it. And if you are not able to do some of the questions, because some of them are fairly simple, some of them are a little bit challenging, I want you to go ahead and type in that tiny URL, and you will have a video there that will go over all of these questions together. Now, you don't have to watch the video in its entirety. You can fast forward to the questions that you really need assistance with. So pause the video and pick some of the questions here that you find to be somewhat difficult. Okay, so then we're gonna go ahead and jump in right here. If you are online, I'm sorry, but unfortunately I decided to add this in the last minute. You do not have this in the white guided notes, but you can certainly answer the following 3 questions just on a separate piece of paper. So today we're gonna find the second derivative using the implicit differentiation rule. And this is what you will have if you were in my class in person. And as you can see, the questions are actually not that difficult, but what is difficult is the fact that you are finding the derivative twice with implicit differentiation. And I want you guys to practice with it because I don't want you guys to feel uncomfortable doing this online. I mean, there are times when teachers actually show you something fairly simple, and then you take the AP exam and you're like, wait a minute, that is really, really hard. You know, that this depth of knowledge was like on a scale of 5, you know, and she taught us something that was on a scale of 1. So I don't want you guys to feel difficult, you know, or a little bit unprepared for the actual questions on the test. So that's why I try to give you guys like a variety of level of difficulty. We'll start with something easy and then we get to somewhere medium. And then like the third day that we spend on it, I'm going to kind of like go on full force to make sure you guys understand it. And that's why I also use a lot of free response questions from the actual AP test, because I want you guys to feel comfortable with it. Okay, so let's go ahead and move forward with this. Okay, so looking at this first question here, it appears like I lost something along the way. What happened to my slide? Sorry, I'm like talking to myself because I actually managed to lost or lose the slide here, but I am pretty sure I will be able to find it. And yes, I am able to find it. Okay, so let's go ahead and take a look at this. Okay, so number 45, we're gonna find a second derivative of this. I mean, looking at it the first time, it doesn't look too bad. So the first derivative, okay, is gonna be 2x plus 2y dy over dx equals 0. That's the first derivative, but I need to find the dy over dx. So I am going to move the 2x over to the right side. That becomes a negative 2x. And I'm also going to divide the 2y on both sides. So dy over dx equals negative 2x over 2y. Ta-da! Not too bad. First derivative. But I'm not done yet because this right here is dy over dx. Now I want to find dy squared over dx because I want to do this twice. Okay. And so what I'm going to do is, as I look at this, there is no way for me to avoid the quotient rule. So I will have to do it, unfortunately. So f equals negative 2x, f prime equals negative 2, g equals 2y, g prime equals 2 dy over dx. And I am going to have a g squared, which is 2y squared, which is 4y squared. Make sure you distribute the 2 to the 2, or the square to the 2. All right, so now that I have this, let's go ahead and find my quotient rule. So f prime times g is a negative 4y minus f times g prime is a negative, so double negative makes it a positive, 4 x dy over dx. I'm trying to be very careful in how I do this. All the way divided by 4y squared. Equals, oops, oh, hello, go back, 0. Okay, so right now what I can see is I see that they both have a 4 on top and bottom, and that's good because that means I can cancel it. Remember, in order to cancel something, you will have to factor it out. So 4 negative y plus x dy over dx. And because this relationship is a multiplication, I can now cancel that. So I have a negative y plus x dy over dx equals y squared over y squared equals dy squared over dx squared. My pen is acting up a little bit. Okay, so then what I'm going to do is looking at this part, given the fact that the dy over dx is what I found in the first derivative, and the first derivative is dy over dx equals negative 2x over 2y, I can rewrite that as a negative x over y, which is what dy over dx was. And I'm just going to use substitution to substitute that in. I know, I hope your mind is blown. Yeah. So then what I have here is a negative y plus x times negative x over y divided by y squared. So then what I'm going to do is I need to go ahead and algebraically simplify this. So I'm going to multiply this out. So it's a negative y minus x squared over y divided by y squared. And I don't like having a fraction within a fraction. So if I were to go ahead and make that a y and multiply this by a y, so that way I have a negative y times y is a negative y squared minus x squared over y, my common denominator is a y, then divided by, here's a divide, y squared. I can rewrite this as, and I'm just going to erase this, times 1 over y squared. So then that will give me a negative y squared minus x squared over y, because it's multiplied, 1 plus 2 is to the third power. And that is my answer. Oh, one more thing. To make this look even more fancier, you should be able to see that another way of writing this is going to be a negative 1 times x squared plus y squared over y cubed. And remember in the beginning of the equation, x squared plus y squared equals 4. So I'm going to replace that with a negative 4 over y to the third. And that's my answer. Final answer, promise. And if you look at it, that answer is the same as this one there. Whew, I hope your mind just went on a trip there because that was a little bit crazy. All right, so I'm gonna have you go ahead and try this one, number 47. So pause the video, your answer is actually right here, and give that one a try. So follow the steps, the same steps that I did before. All right, if you wanted to kind of go along with me, that's fine too. There's nothing wrong with that. So the first derivative is 2x minus 2y dy over dx equals 0. Then I'm going to go ahead and move the 2x over to the right side. So I have a negative 2x dy over dx, and I'm going to divide by that negative 2y. And I can see that dy over dx is equal to a positive x over y. And I'm going to keep it like that because I'm going to need that later on for probably replacing it back. So that's my first part. Now my second part is to go ahead and find dy squared over dx squared. So to do that, unfortunately, again, I'm gonna have to use the quotient rule. There's no way of avoiding that. So f is gonna equal to x, f prime is 1, g is y, g prime is just dy over dx, g squared is going to be y squared. So I'm gonna go ahead and do f prime times g, so that's y, minus f times g prime, that's an x dy over dx, all the way over y squared. And again, you are going to replace the dy over dx, which is equal to x over y. So I'm going to do that. I'm going to go ahead and replace this part right here with y minus x times x over y. So my numerator is going to give me an x squared over y squared. So it kind of looks very similar to what we did in the beginning. And so again, I don't like having a fraction within a fraction. So I'm going to make it a common denominator. So when I have that y multiplied top and bottom, I have a y squared minus x squared over y. Come on, pen, just a few more minutes. And then I have a division right here. So I'm going to put a divided by y squared. But you guys know another way of writing that is just times 1 over y squared. So because this is timed, the numerator is just multiplied by 1. So it's y squared minus x squared divided by 1 plus 2 is y to the third. Now, do not be tempted to cancel the y cubed or the y squared because you can't. There's a minus sign in between them. So they're kind of like married together in this overall chain. But what you can do is you can simplify this because you do know that x squared minus y squared is equal to 36. So if I could get it to look like x squared minus y squared, then I can replace 36. Well, unfortunately, I would have to go ahead and multiply a negative 1, or I guess factor it out. So I get a negative y squared plus x squared over y cubed. This is just a commutative property. So you know that negative y squared plus x squared is the same thing as x squared minus y squared, right? And you know that x squared minus y squared is equal to 36 from right there. So you have a negative 1 times 36 over y cubed, which is just a negative 36 over y cubed. And that is your answer. Same answer. All right, so let's go on to the next one. And this is your last one. It says find the tangent line equation to that derivative right there. And since this is only the tangent line equation, you don't need to have the second derivative. You just need to find the first derivative, but it's a pretty holistic question. So first things first, I don't like the way that it has a radical, so I'm going to rewrite it. So x to the 1/2 plus y to the 1/2 equals 5. So then I'm going to use my implicit differentiation. So I'm going to bring down the 1/2, just like what we did in the warm-up. So 1/2 x minus 2 over 2 is negative 1/2, plus 1/2 y minus 2 over 2 is a negative 1/2, but don't forget that dy over dx. Derivative 5 is 0. Then I'm going to go ahead and move this over to the right side. So I have a 1 over 2 y to the negative 1/2 dy over dx equal to a negative 1/2 x to the negative 1/2. And at this point, I don't like the fact I have a bunch of negative 1/2, so I'm going to rewrite them. So I have 1 over 2y, positive 1/2, dy over dx equals negative 1 over 2, bring down the x to a positive 1/2. To get rid of the 1/2, I'm going to multiply both sides by 2. That cancels, and I'm left with a negative 1 over x to the 1/2 on the right side. And then also what I'm going to do is, to save some space, I have a 1 over y to the 1/2. So multiply by 1 to the 1/2 on the numerator. And the y to the 1/2 cancels. And on top, I am going to get y to the 1/2, because 1 times y to the 1/2 is just y to the 1/2, equals a dy over dx. Yay. Now I have my first derivative, which is just my slope. So now I can go ahead and plug in the x and y, but I might want to rewrite it so it is in a radical form. And once I do plug it in, I have a negative square root of 4 over the square root of 9, which is a negative 2 over 3. And that is my slope. So to find the equation for this, you could either use slope-intercept form, or you can use point slope form, whichever one you feel comfortable with. And let's just use point slope form, because I always use slope-intercept form. So that one is when you have y minus y sub 1 equals m times x minus x sub 1. So y minus 4 is equal to a negative 2/3 times x minus 9. Now, you could decide to keep your answer this way, or you can move it a little bit further, distribute that out, and you have y minus 4 equals a negative 2/3 x plus 18 divided by 3 is just going to give you a 6. And then, of course, you add the 4 over to the right side, which will give you a 10. And this is your equation. Or you can just leave it like that. But, depending on what the multiple choice answer gives you, I will probably include both if it's free response. But anyways, that's just me. All right, you guys. So that was actually plenty of practice for today. So I hope you guys have a good night, and I'll see you guys next time. As always, stay safe and healthy. Take care. Bye-bye.